So dear students, welcome to our class on basic class of gases, that is the kinetic theory of gases. Before we go into the actual kinetic theory of gases, I would like to impress upon you that atmosphere is a colorless, waterless and tasteless physical mixture of gases enveloping the earth on all sides. Air in its horizontal motion is known as wind, air in its vertical motion is known as air currents. So these are the basics. The direction from which wind comes is known as windward, the direction to which wind goes is known as leeward. Okay, so these are the fundamental things just before we go into the gas laws. Basics one, it's not advanced. I assure you that in the classes to come we are going to understand what are the applications of gas laws as far as agriculture, meteorology, in crop production, in plantation crop production, even in the animal rearing, even in the forestry also is concerned. We understand. Now, just try to understand what are the gas laws. This also I am taking from my own book, Basic Principles of Agriculture Meteorology, written by me only. So way back in 2000, 2002, started 15 years earlier to that one, page number 98, 99. So here I had given them because these are the basic laws. It never changes. They have not changed. They are not going to change. But anyway, I would like to enlighten you what are the gas laws. Gas laws, what Radha wrote in his book. Good. Now, so to explain the behavior of the gases, kinetic theory has been very successful. The essential features of the kinetic theory of gases are: all gases are composed of molecules. All gases are composed of molecules. The molecules of a particular gas are alike, okay, and differ from the molecules of the other gas. Nitrogen from oxygen, oxygen from carbon dioxide, carbon dioxide from nitrogen, like this, the first one. The molecules are mere point masses. The molecules of the gas are mere point masses. Their dimensions are negligible as compared to the distance between them, okay. The distance between them is more as compared to the dimensions. The molecules are continuously in motion. Never and ever they are static. They are continuously in motion. They have velocities in all the directions ranging from 0 to infinity. The velocity of the molecules increases with the temperature. Troposphere, stratosphere, mesosphere, ionosphere, exosphere. Of course, even though the troposphere has a lot of gases, still as it goes, it goes on spreading. So in a steady state, the molecules are commonly colliding against each other and also with the walls of the containing universe. In this room, okay, gas molecules are moving, and they are continuously colliding with each other. So that's what is the meaning of it. Between two collisions, a molecule moves in a straight line, and the distance is called free path, F-R-E-E, free, P-A-T-H, path. This is the free path. Now, see, the collisions are instantaneous. Instantly collisions occur, and the sixth gas law is that in a direct impact, the molecules begin to move in the opposite direction with the same velocity. So these are the 6 basic laws. For your academic interest, I would like to present all gases are composed of molecules. Every gas is composed of molecules. These molecules of a particular gas are alike. Okay, second thing is molecules are mere point masses. Third one is the molecules are continuously in motion. Fourth one is in a steady state, the molecules are continuously colliding against each other, which we call it as the free path. The collisions are instantaneous, and in a direct impact, the molecules begin to move in the opposite directions with the same velocity. So these are the basic laws. Now, see, I would like to just read these 3. What is pressure gradient force, Coriolis force, centrifugal force, frictional force in an elaborate way in the days to come. But I just would like to read and explain to you what is a pressure gradient force. This force is given by pressure decrease per unit horizontal distance and acts in a direction perpendicular to the isobars. Once again I will read. This force, pressure gradient force, is given by pressure decrease per unit horizontal distance and acts in a direction perpendicular to the isobars. Isobars are the lines drawn connecting the points of equal pressure. Okay, when isobars are closely drawn, there is a steep pressure gradient. When isobars are drawn apart, there is no steep pressure, slope pressure gradient is there. So pressure gradient force is given by pressure decrease per unit horizontal distance, not vertical, horizontal distance. So, what is the Coriolis force? Coriolis force is the force exerted on the molecules by the rotational movement of the earth. Coriolis force is the force exerted by the molecules of gases in the atmosphere, nitrogen, oxygen, carbon dioxide, argon, water, all these things, because of the rotational movement of the earth. Coriolis force effect is almost negligible near the equator, but from the equators on both sides when you go, the Coriolis force is going on increasing. Just I read once again, the force is due to the rotation of the earth. The force is because of the rotation of the earth, Coriolis force. Okay, the Coriolis forces causes all winds in the northern hemisphere to move towards the right, and those in the southern hemisphere to move towards the left with respect to the rotation of the earth. Okay, at the equator the Coriolis force is almost zero and is maximum at the pole. This is what I would like to tell. What is the centrifugal force? Centrifugal force, very interesting. When an air particle travels in a curved path, air molecule moves in a curved path, what happens to that? An acceleration towards the center of the rotation is resulted. Due to this acceleration, a centrifugal force operates and makes to throw the particle outward radically. So, this is what I have already told in the basics class of the wind. Again, so what is the frictional force? The last one is the frictional force. The roughness of the surface provides frictional resistance to the air motion. Say for example, let us take this one. Okay, when I move like this, okay, frictional force acts. If it is smooth, it will go. If there is the friction, it will stop. This is what we call it as the frictional force. What is that? The roughness of the surface. This is a smooth surface. If roughness surface is there, the roughness of the surface provides frictional resistance to the air motion. This force acts in opposite direction and reduces the wind speed. Wind speed will not be just like land. No, it won't go. It goes on increasing, decreasing, becomes zero at the surface of the earth. How? Because of the frictional force. Okay, this force reduces the wind velocity, it reduces the geostropic wind. The other day I told geostropic wind, it reduces the geostropic and centrifugal forces to give resultant in the direction of the pressure gradient. The winds are turned towards low pressure and flow across the isobars at an angle of 15 degrees on sea and at 30 degrees on the land due to high friction. See, land has got high friction, sea has got free friction. So, this particular frictional force, acts very instantaneously depending upon the roughness of the surface. If I am not confusing you, the force that is exerted by some roughness is called as the frictional force. The implications of these particular basic laws of the gases we try to understand in the advances, even in the applications. Till that time, may God bless you. All the very best.